Welcome. Async versus coroutines. Finally something that isn't dots. Okay. Thank you. So, my name is Johannes Ahvenniemi. I come from Seriously Digital Entertainment, Finland, Helsinki. Woo! Who else is from Finland? Quite a few. It's totally the place to be if you want to make games. And who here is a coder? That's good, most of you. Phew. Okay, I'll start by telling about me, so you can better relate to what I'm talking about. A bit like an introduction, how I ended up here talking about this specific subject, and also trying to buy some credibility. I started quite young with BASIC on Amstrad. We did have a PC also, but Amstrad was more approachable. I would just type in commands and it would print and draw stuff for me. That was fun. I did move on to QBasic on PC later. Who's used QBasic? Yeah, that was a lot of fun, right? You would just type this sequential logic and do amazing stuff. Life was so simple back then. I did some C++ in between, but when Java came, I was able to make easily distributable browser games. So I made one, something like 10 people played it. That was fun. But then I realized how many players I would get if I downgraded to Flash, because that's how I saw it. Flash had a very bad reputation already back then. But I'm glad I did, because I did have some mild success with my Flash games. And it's also how I landed my first actual job in the industry, at Rovio, creating browser versions of Angry Birds. That was huge. I also did some C++ and Lua at Rovio. C++ remains my favorite language for game development due to its power, but only a subset. I'm not using the whole thing. I'm not crazy. Other stuff in my toolbox, mostly web dev and game dev related stuff. But I'm also a fan of functional programming. So I use Clojure whenever I want to expand my thinking, because that's what functional programming does to you. It's good for your soul. I've been a Unity developer since 2014, when I joined Seriously, developing the hit puzzle game, Best Fiends. I hope some of you have heard of it. Best Fiends is a free-to-play mobile game. And as free-to-play developers know, it's a lot about UI. You have these sale pop-ups, you have gift boxes, inboxes, social features, prompts, GDPR. There's a lot of UI that goes into it. That's okay, that's fun work, but it's really challenging because these pop-ups consist of buttons, and these buttons are handled with callbacks. And as you start chaining these callbacks, you end up in what web developers know as callback hell, and that's another nice place. So it's an actual problem in Unity also. Funnily, in JavaScript, we got rid of these callbacks a while ago, thanks to async. So we were able, once again, to write this sequential code that I used to write in QBasic back in the days. So I was really happy to finally see async in Unity. And this is how we get to our topic. Async. And coroutines also. Mostly about async because it's the new and exciting thing, right? It really is more about async, but not because it's new and exciting, but because it's new and scary. At least for me, it was. but also about coroutines, because at least for me, when coroutines came, it was challenging to me to understand the difference between the two. They seem to solve the same set of problems. So let's get to the topic. And let's start with coroutines. Who has used coroutines before? Oh, almost everyone. They're familiar to us, right? They're a pretty old concept. What are they good for? According to Unity documentation, not their words, these are mine, it's useful for spanning logic across multiple frames. They are about cooperative multitasking, so they're single-threaded, which is good because Unity engine features can only be used from the main thread. They're implemented using C# generators, so it's not exactly a language feature, but under the hood, there's no magic. And here I want to specify that this talk is about the engine feature and not the language feature. So when I'm saying that something is or isn't possible with coroutines, the same might not apply to generators. So it's an old concept, it's familiar from many languages, I just picked a few. It's a proven good concept. We should be using it. Then we have async and await. This is actually two features I'm talking about, async and await, but for simplicity, I'm going to refer to this duality as only async. I hope that's okay. When async came to Unity, there was a lot of discussion online about how you can now replace your coroutines with async for whatever reason. I'm going to argue against that. I'm saying that async is not intended for replacing coroutines. It's intended for something else. They can look very similar. Going to another language, it can be hard to tell them apart. For example, Clojure, my favorite functional language, borrowed Go routines from Go, but called it async. So what are they good for? According to Microsoft, again, I reworded it a bit to make a point, they're useful for handling non-blocking I/O, meaning user input, and also for long-lasting routines, which means threading, but I'm skipping threading mostly in this talk because I want better focus, and no one really uses threading anyways. You can use dots for that. It's an old C# feature, originating from functional languages. And from C#, it has spread to many popular languages, pretty much as is. So it's clearly a very successful feature by Microsoft. Well done. And finally, we got it in Unity 2017, and 2 years later, as a slow adapter of new technologies, I'm here wondering what to do with them. So let's get on. I composed a list of the differences, and the list ended up being quite long, so hang tight. Some of these don't seem meaningful at first, like the second one. Why would you want to run asynchronous code synchronously? Some of them are quite weird, like coroutines not always exiting. What's up with that? And some of them are pretty much lies. So I will go through them one by one with code examples so we can get a deeper understanding of the differences. So starting with the first one. Coroutines don't have return values, but async does. I think this is the most important one. This is the real reason to use async over coroutines. If you need an asynchronous routine to return a value, you use async. The rest is just details. Let's see what this means in code, but before that, a brief disclaimer. These code examples are really bad. They're meant to present a point. They're not meant to be used, so please don't use them as is. If you have questions later how to implement them properly, you can contact me or figure it out yourself. It's not difficult. So first, code example. Async on the left, coroutines on the right. It's the same, they do the same thing, they look different. What they do is that the logic waits for the user to press any button, and then it prints the name of that button. The async version is pretty simple to understand. That's what it says. Await for select button, log the name of that button. The coroutine, on the other hand, it seems like you can have return values with coroutines, but not if you value your pride as a coder, I think. I might have intentionally made it look worse than it is, but really, I wouldn't dare to do anything like this with anything more complex. I'm still going to argue that coroutines don't have return values. Async does. And this makes the async implementation really beautiful. It's as if it was made for this, and I think it was. It was made for asynchronous input, which a button press is. So to understand the rest of the presentation better, it's vital to understand somewhat what's going on here. So I'm going to spend a bit more time here, starting with the press button at the bottom. Here we wrap the callback of the button in an asynchronous task. And when the button is pressed, the callback is triggered, then we return the button. Next, we have select button, which finds all the buttons available and starts this press button task for each one of them. And it waits for one of those tasks to finish. And then it returns the result of the first finished task, being the button that was first pressed. And these become kind of utility functions. You don't have to write them every time after this. Your code simply becomes cleaner, I think, if you use async instead of callbacks. So the point of this example was to convince the non-believers that async does have a use case. There is a use case, at least here, where coroutines don't really cut it, but async really shines. I hope everyone's now convinced that async can be good. So, next one. It's a less exciting one, quite a weird one. Why would you want to run asynchronous code synchronously? Well, our games are asynchronous, right? They happen over time, and they take in input along the way. But what if we already have the input? What if we want to run our game in batch mode? Let's say it's for testing purposes, or we're making a score validator. So we have the inputs. We would like to just give them as parameter and get the end state of the game out. Now there's nothing we should await there. It should be an instant synchronous operation. Turns out this is tricky with coroutines. If you look at the outputs, we lose one frame with the coroutine. We're trying to avoid yielding one frame with the if false, but we lose the frame somewhere anyways. With async, we don't have this problem. So with async, we at least know that if the need be, we can run it synchronously. And that's good. 1 point for async. Third one is kind of related to the previous one. What if we want to run the game in the cloud? Now, coroutines are an engine feature. If you want to run your coroutines in the cloud, you need to put the engine there. But if your game doesn't really need the coroutines, you would rather not have the engine there. It's going to be much simpler and faster to just run your pure logic in the cloud. Async is a language feature, so you can freely use async in the cloud without the engine. I don't have a code example of this. I'm letting Drake explain it for you. Of course, if your game needs engine features like physics, for example, there's no way around it. You need the engine in the cloud. But if you're making, let's say, a puzzle matching game like we are, we don't need the engine to run the logic. We can just put the pure logic in the cloud, as long as we're using async and not coroutines. Almost halfway. Coroutines don't support try-catch. Async does. Pretty straightforward, but it's actually a pretty big one, because now we can finally do this. And this is not only about try-catch. It's actually about how we can now structure our app as one sequential flow. Here we have the root awaiting the main menu, which is maybe awaiting the game scene, which is awaiting the win scene, awaiting the gotcha scene. And if we have a bug in this chain that throws an exception, that exception will propagate all the way to the root. And now we have a chance to catch it and load, because we know we lost everything. We know there's nothing to do anymore, nothing to be done. We can just show an error scene saying that we're sorry. Please restart the game. With coroutines, we can't simply do it. It won't even compile. They're not meant for this. Coroutines don't preserve call stack, but async does. This is kind of a lie, but it's a pragmatic way of looking at it. So I'm just going to go with it. Who thinks it's a good thing to preserve the call stack? Who thinks it's a bad thing? The rest of you know it's a trick question. Are you spaced out, or you're artists? Okay. Turns out both have pros and cons. First example. This is a null ref exception, similar implementation on async and coroutines. The coroutine log is less intimidating for sure, but it contains less information. We see that the exception came from do stuff, but who called do stuff? Who passed the null value to do stuff? Maybe do stuff didn't do anything wrong, the error is somewhere else. If you work with coroutines, you must have noticed this. It really sucks. Async, on the other hand, does give you all this information. It's a bit messy, but it's there. Here we see that do stuff was called by do something, which was called by start. Maybe we didn't have a button field set in start, and that's why we get the exception. Now we have something to work with. The output is messy, but you'll get used to it. This, on the other hand, you don't get used to. Like, that's not even the whole stack. That's only everything I could fit on my 4K monitor. Just keeps going both ways. It's insane. I hope Unity does something to this. You don't want to be clicking through that with your mouse to find your own function at the leaf node. Keyboard helps a bit. Took me a while to find that. So, yeah, but you can live with this. Here's an actual warning about the stack. Now, yeah. Unity doesn't automatically unload assets that you reference from your script execution stack. Now, if you did what I just advertised, you build your game sequentially, a root awaiting main menu, awaiting game, awaiting win scene, awaiting gotcha. Now you have this whole stack of logic referencing all these scenes, and Unity won't unload those scenes for you. So don't do as I advertised. You could try using unload unused assets. That will unload assets that are still referenced by the call stack, but somewhere you might have a piece of logic that depends on those assets not being unloaded, so I can't recommend doing that. My suggestion is to just don't go crazy with the stacking. Especially don't await non-additive scenes from non-additive scenes. Awaiting a pop-up from a non-additive scene makes a lot of sense. That's okay, but just don't go crazy. This is also a problem with coroutines, or could be, but just never tends to be because of the way we use them. You never really stack them like this. Okay. This is also kind of a lie, but it's a pragmatic way of looking at this. Here we have very equal implementations. In both ones, we can see the debug log, but the exception is not there in the async implementation. What? Well, this is a stupid example. You would never write this kind of code. You would never have an async task function that you are not awaiting. But if you don't know this, well, the compiler gives you a warning, but if you don't regard compiler warnings, then you're going to end up with weird stuff, like your logic just silently stopping because you don't see the error. So this is supposed to scare you a bit, the most enthusiastic async people. That you can't just jump into new technologies and accept it to be perfect for you. There's going to be pitfalls. You have to be mindful of new technologies. Coroutines don't always exit. The async does. This is a scary bit of code from my current project. We might have a memory leak. So here we allocate a render texture, assign it to a UI component, and for the next 100 frames, we apply filters and stuff to the texture, creating this animated effect, something like transitioning from world map to battle, like in Final Fantasy VII or many old games. And then finally, we release the texture. This is important. Unity won't do this for you. But what if the mono behavior owning this coroutine dies in the middle? Surprise, surprise, it won't reach the finally block. And I think that's just crazy. What's the point of having a finally block if you don't finally reach it? I don't really know who to blame for this. Async works. So if you ever have a using block or a finally block in your coroutine, check it out. You might have a memory leak there. And as we just saw, the lifetime of a coroutine is tied to a mono behavior, but the lifetime of async is handled manually. This is a big win for coroutines. It's also a big win for async, but for different reasons. But without this, I don't think this coroutine would have a place in our world. this talk would just be called 10 Reasons to Love Async. Let's see how this is useful. Here we have a mono behavior that starts this rotation function that rotates it every frame, seemingly forever. But after 1 second, the mono behavior destroys the game object. Now the coroutine acts at least as I would have thought it would. It would just stop. We don't hear anything about it anymore. But well, now async thinks it's a good idea to show exceptions. But that's not really an exception we want to see. It's kind of meaningless. We get it from accessing the transform of the destroyed game object. But it's like, it's not an exception we want QA to come asking us about. We can say that it doesn't matter, the exception is okay. But as they start stacking up, yeah. So how do we fix it? Well, we add cancellation tokens. That's the async way of managing lifetime. So we create the cancellation token source and pass it to the rotate function, or the token of it. And when the timer runs out, we cancel it. Does it fix it? Well, it doesn't, because if something else destroys the game object before the timer runs out, we are late with the cancellation, and we get the exception again. Do we put the cancellation in on destroy? We could maybe do that, but now we're adding complexity that we don't really need. We could just go with the easy coroutines, as we just saw. So I think this really justifies the existence of coroutines. They still have a place in our world, a place in our hearts. Let's not forget about them. Finally, coroutines are familiar to most Unity developers. Async isn't. We already saw some surprising stuff today. We used coroutines for years and we built beautiful things with them. There's no reason to just stop using them and switch to async because some dude online is telling you to do it. But if there's still someone here who thinks that it's a great idea to ditch coroutines and go with async all the way, maybe that dude from online is here, stay put. In this example, next section, we will implement something using async, and we will see a bunch of issues that come with it. So we're creating a prompt. This is what we do in free-to-play games. We do a lot of pop-ups and prompts. Yeah, we do other stuff as well. But this is a simple thing that we have 3 buttons. It's an additive scene on top of another scene with more buttons. We ask the user to accept or decline GDPR or something. And it's a pretty basic thing. And boom. Here we have a mono behavior describing the pop-up. It has the 3 buttons. It has one static asynchronous spawn function that uses a few utility functions. It loads the scene, finds the mono behavior within it. Then it waits for one of the 3 buttons to be pressed. And if the pressed button was the accept button, then we return true, indicating that the player accepted the COPPA compliancy or something. But we forgot something. You saw that was pop-up prompt 1. This is now 2. There's going to be a few more. We forgot to implement the Android back button. It's a mobile game. We have to support this. Luckily, we have a utility function for it. Wait for press back button. It's pretty simple to implement, actually. And now here is where async really shines. It's really good at handling these multiple simultaneous tasks. Here, we wait for either one of the UI buttons to be pressed or the Android back button to be pressed. And if the finished task was pressing a UI button and the pressed button was accept, we return true. Everything else results in false, including the Android back button. But now what's that weird await in the middle? The comment tries to explain it, but doesn't make much sense. Oh, sorry. Yeah. Turns out that if the task finished because of an exception, maybe one of the buttons was null, it wasn't assigned, then the select button will throw an exception and finish because of that. Now, when any is happy with that, it's still a finished task, it's going to return it. And it won't tell us that it failed. We have to dig out the truth ourselves. And of course, we want to see the truth. We want to know if it finished because of an error. This is a neat way of doing it. Maybe a bit hacky, but neat. If we await the finished task again, and it was finished because of an exception, it will rethrow that exception, exposing it to us. Just a bit of boilerplate, but we can live with it. What else did we forget? We forgot the manual cancellation that I was talking to you about earlier. It's really important. In general, every async function should take a cancellation token. In our current project, we don't have a single asynchronous function that doesn't take a cancellation token, except for one async void start at the very root of the app, where it all starts. So let's add it, and it's not that bad, just one more CT at the end of everything. But there's still one thing we forgot about the manual management. What happens to the task that didn't finish first? What if the back button was pressed and not a UI button? Well, the select button task will still be running in the background with all the references to the buttons and everything. Of course, we don't want that. We want to clean it up. So we have to cancel it after when any returns. We can quite easily do this with linked cancellation tokens. So we link the original cancellation token using create linked token source. And now when any returns, we can cancel the remaining tasks. This is much better, but we just added a memory leak here. The create linked token source needs to be disposed, or the cancellation token source created with create linked token source. Cancellation token source is implement idisposable. It's not usually needed, but if it's created with create linked token source, it needs to be disposed. Otherwise, we have a memory leak. So let's do it. We put it in a using block. That's it. Not bad. Now, what's next? Yes, we forgot something important again. You fire up the game, you open the pop-up, you close it, and that's when you realize what you forgot. The pop-up is still there open visually. The logic exits, but nothing unloaded the pop-up. And the design spec says that it should animate the close. I hate those. But it sounds like yet another asynchronous routine. We do something over time, we animate the pop-up closing, and then we dispose it, unload it. And turns out that this kind of it's actually a fire and forget routine, because it's only a visual thing, because the logic doesn't care about it anymore. As soon as we start the animation, we know it's going to animate and unload the pop-up at some point, but it can't affect our app logic anymore. You can't go and press any buttons in the pop-up while it's closing. That's good. So turns out this is pretty easy to implement with coroutines. So we turn our using block into a try finally block. Using is anyways just syntactic sugar for this. And now whatever happens in the logic, whatever exception happens, whoever closes what, whoever cancels what, we don't care. When the logic exits, for whatever reason, we just fire and forget this routine that animates the pop-up closing and unloads it at the end. You don't have to care about cancellation tokens or anything. So we did find a use case for coroutines in the end. Yay. And this is it. This is our final form. It took us a while to get here. Was it worth it? I think it was. This is actually not a trivial thing we did here. UI has lots of hidden, really difficult problems that we solved without even noticing. For example, has anyone had to deal with bugs caused by double tapping something? QA double taps a button and now you have two pop-ups open and your game is most definitely broken. Or even worse, tapping two buttons at once. Now you have two different pop-ups open. Well, these are no problem with this pattern because only the first input is handled. Only the first button press is returned by when any, and only that is handled. The second button press just does nothing. This is the first one, pressing stuff behind pop-ups. Right? Has anyone had these issues? You have this pop-up, and behind it we have a settings button. QA goes and presses that, and now we have a settings pop-up on top of this, which was not intended, and there's just so many ways of breaking the game with that. So the settings button there shouldn't be active. That's why it's overlaid like that. But sometimes you just miss these blockings of input. Well, here it's not a problem again. If the scene that loaded this pop-up was implemented using the same pattern, because now there should be no piece of logic handling the pressing of that settings button. There should only be one line awaiting for this pop-up to return true or false. Those buttons in the background do nothing at this point in your logic. That's kind of beautiful. This pattern is probably worth another talk. I'm just going to leave it here. But this example hopefully showed you that async can be really powerful. But it comes with, of course, great responsibility. There's much you have to take care of with that. It's the kind of responsibility that coroutines don't have. Coroutines you can just go and use, and it's all fun. So finally, how to choose when to use async and when to use coroutines. I called these rules of thumb here, but in my current project, they're actually rules. Not because we like rules, but because everything just works if we do it this way. We never even need to break the rule, really. This list came from a pretty practical approach. We didn't have it when we started the project. We just started using coroutines and async, and slowly we developed an intuition for picking one, and eventually we were able to formalize this list. And while it came from a practical perspective, it ended up matching the documentation pretty well. So we should have just started with the documentation. Because, well, what Microsoft says, async is good for handling I/O asynchronously. That's pretty much what we've done here today. We've handled inputs from user with async. And how about coroutines? According to Unity, they're good for spanning logic across multiple frames, but async can do that as well. So how do we justify using coroutines. We have to specify our use case a bit better, and this is what we ended up. We use coroutines for fire and forget routines. Because fire and forget routines, by definition, don't return anything. And the biggest point in async was that it has return values. So we don't need async for these fire and forget routines, and we don't need the responsibility that comes with async. We can just skip all that and go with plain old simple coroutines. In the end, you will have stuff like tweens that are neither handling input, but they're also not always fire and forget. For example, if you have a tween between two inputs, and the user has to watch the tween to end before doing the second input, we can't forget about the tween. It's not a fire and forget, we have to wait for it. Well, and of course, fire and forget routines are full of these tweens. That's mostly what they are. You fire this here and that there. They fly around. So are tweens coroutines or async? In our project, we ended up duplicating them, so they can be both. That's, of course, not optimal. Duplicating logic never is optimal, but it works for us. It's never been a problem. So now we avoid intertwining them, because if you start intertwining, mixing and matching coroutines and async, I think all hope is gone. That's my experience. Notice that you can still branch off, like we did earlier. We had this async logic, and we started a fire and forget routine from it. But as long as the fire and forget routine doesn't turn out to be a returning routine, intertwining with the original async flow. So don't intertwine them. Branching is okay, though. And that's it. It's this simple, at least for us. I don't know your projects. These might not be strict rules for you. You might have different needs. But I hope they give you some guidance. And this ends my talk. Thank you for coming. I hope you learned something.